Hi, welcome to my presentation, Basics in Cost Optimization for Camera and Lens Selection. Before we start, let me present myself, the company, and give you a summary of the points we are going to cover. My name is Gabriele Cobelli. I am a sales engineer for Get Cameras. My background is technical, so I have a great knowledge of the products. I advise customers to build the most cost-efficient setups. We are the exclusive dealer of Daheng cameras in Europe, with headquarters and warehouse in the Netherlands. Daheng is a manufacturer which produces more than 100,000 cameras per year and has more than 25 years experience in the field of machine vision. Get Camera and Daheng work together to provide the best advice and support. Thanks to our smart and modern business model, we are able to offer the best price on the market with fast and efficient pre-sale and, not less important, post-sale support. Here is a quick overview about the points we're going to cover. The goal is to show you how we select the cheapest camera and lens to suit the project needs with the best image quality. We're going to cover the price and the characteristic of USB3, USB and gigabyte connection, the effect of the shutter selection, color and against mono selection, and the resolution. So which resolution is the minimal that you'll need and the optimal to choose from, and then the lens selection part. The goal we have at Get Camera is to provide the best hardware for the customer's project, choosing the most cost-efficient product, so to find a setup which delivers the result expected for the best price, the most convenient price. There are, of course, many options to choose from, and obviously, the most performant the camera is, the better it is at the specific job. However, we are here to offer a specific and a targeted solution, so the customer saves money and does not have excessive and unnecessary hardware if it is not required. In most cases, the project requirements are static, so it is not convenient to buy a setup with too much overhead, too much power for the future, because the technology evolves, product age, and so forth. The best solution is to buy the things you need for the project. We have a selected portfolio of material which we guarantee to provide high quality images and has the best price on the market. The presentation will show you step for step how to select the material. It is a straightforward flow. We are going to keep it simple and basic today. If you want to have more specific calculation and suggestion, you can get in touch with us, of course. The first step in the selection of the camera is the connection type. USB2, USB3, gigabyte with the various speed, the 1 gigabyte, 5 or 10 gigabyte. Those are the interface we offer. Let us start by pointing out that the 5 gigabyte and 10 gigabyte connection are very new, and therefore they are still very expensive compared to USB 3 and GigE and USB 2, of course. 5 gigabyte and 10 gigabyte are really only selected if this is the specific need of the customer. On the other hand, on the other extreme, the cheapest of the connection, USB 2, we still offer, but is being phased out and rarely used in new projects. So we will focus on USB 3 and standard 1 gigabyte connection. Those are mature and well-known connections which are actually suitable for the vast majority of the project. We begin with the cable length. USB 3 cable length, maximum length is 4.6 meters. Gigabyte Ethernet is up to 100 meters. So the first question to help you select the camera is the connection. What is the length between the camera, the distance between the camera and the host PC? Is it more or less than 4.6 meters? It is possible to extend the USB 3 cable length using optic fiber extenders. Those are very expensive, but in some application you need the USB 3 capability and a longer distance than 4.6 meters. So in case you do, then you can get in touch and we can check together for the solution. The following point is bandwidth. USB 3 is 4 times faster than Ethernet 1 GB connection. Your frame per second limit is based on this, so how much bandwidth is available. Since the bandwidth is more with USB 3, you can connect more cameras and still to be able to maintain the frame rate for your application. Price-wise, we should think that there is basically no difference between USB 3 and Gigabyte. It's about the same. However, there are other factors that influence the price. USB 3 is present in a majority of modern computers. It uses the PC power, so the power is from the PC itself, from the port, so no external power supply is needed. USB 3 also buffers data, so there is never a frame loss. Gigabyte cameras need external power unless you're using PoE, power over Ethernet devices. Of course, you need to have a complete PoE setup. The port of the PC must be PoE, or you must be using a PoE switch or router. PoE is not used everywhere, so if you need to upgrade to PoE, you of course need to invest money. Or even if you don't want to use PoE but you use a local power supply, this is an extra cost which USB 3 does not have. Because the bandwidth is limited with the Ethernet to 1 GB actually, if you want to connect multiple cameras, you will reduce the frame per second each camera can achieve. So you should not forget that an existing network is usually shared among other devices, computer, printers, maybe other cameras. So this further reduces the available bandwidth. So the price of the two cameras is about the same, but the network does have a cost of setup and maintenance. So this should be considered. Another very important point is that if you use only one camera, you may connect the camera directly to the computer. Now, beside the power supply, which must be considered, usually all modern computers do have at least 2 USB 3 ports. So from one camera you will connect it for sure, 2 camera you may still be able to connect it. When it comes to gigabyte cameras, usually a PC does have only one network port. So already when you have 2 network cameras, you more likely need to invest in hardware to connect both cameras at the same time. In the selection of the camera is the kind of shutter used. There are 2 shutters, rolling shutter and global shutter. The question is your object or camera moving while being photographed or not? When capturing moving object, you must use global shutter sensor, because on the rolling shutter, the first and the last line are exposed at a different time. This will cause the so-called wobble effect, the blur. So as the typical used image show here in the presentation, a fan, for example, we show a big distortion of the spinning blades. You should also notice that movement is not only the movement of a single object, but also in the form of camera shake, vibration, the camera being moved by wind, for example. And this blur, this effect will be more accentuated when the system resolution is high. So how smaller we want to see, the more important is to cope with movement. For such reason, global shutter is always preferred. And thanks to the modern techniques to produce the sensor, global shutter just return sharper, crisper images compared to rolling shutter. It is worth mentioning when budget is critical, for instance for high volume project or combined with high resolution needs, where the price gap between global and shutter sensor is very big, it is possible to use a rolling shutter also for moving objects with some limitation. The idea is to capture the image only when all the lines of the rolling shutter sensor are exposed at the same time. This requires a dark environment, a LED light with a strobe controller. Because the setup needs hardware and resources, time to deploy it, this is not always worth the effort. But remember, there is a possibility to use a rolling shutter as a global shutter to save some money. The following point about shutter selection is the price. Global shutters are more expensive than rolling shutters. And the more resolution on the sensor, the more this gap actually grows. Consider that global shutter sensors are actually bigger, so they do require a larger lens to fit, and this is more expensive. So the price between rolling and global shutter, it becomes more marked, more big when you're using higher resolutions. As you can see in this little chart, there is a 12 megapixel resolution used, and the price is 1350, 1348 and for global and 385 for rolling shutter. Not all model of sensor are present in both fashion, global and rolling. So we have to find the best matching solution for your application. But the first choice remains, do you have movement in your setup or not? What is the main difference between color and monochrome camera? Not the price, being exactly the same. If you need to recognize colors from each other in different tones and shade, a color camera is mandatory. Think about wire color recognition, for example. Mono camera can be equipped with color filter to create contrast between opposite colors. Mono cameras can capture visible light and near-infrared light. Monochrome camera produce just sharper pictures. Monochrome cameras are 3 times more light sensitive compared to color cameras. I will explain a bit more in detail about these points. This graphic is showing the comparison between the monochrome camera, the black line, and the color camera, the RGB. You can see the red, green, and blue colors there. Basically, a monochrome camera is capturing the visible light, like RGB, but it does also go further and capture the near-infrared light. A monochrome camera has a clear glass filter installed simply for dust protection, let's say, from the sensor. A RGB color camera does capture the 3 separate colors, of course, and it does have a near-infrared filter installed. This means that with a color camera you can't see near-infrared light. If you were to remove this filter, you could actually see near-infrared light, but you will lose color separation in the visible light. So when you need to see and capture near-infrared light, you either use a monochrome camera or a dedicated near-infrared camera. Let me explain you how a color camera works. White light is of course made by the 3 colors RGB, red, green and blue. On the camera pixels we have some filters. As you can see on the right image, we have 3 filters which basically only allow 1 color at a time to enter and to reach the sensor. Therefore, on each pixel you do lose 2 colors and the camera captures only the one allowed to enter. By doing so, the camera afterward calculates how much of this color enters each pixel. Now, why do we have more green pixels, more pixel actually with green filter? Because the camera sensor, as the human eye, are more sensible to the green light, therefore this is better captured. As you can understand, if from all the white light you only capture 1/3 of this available, you lose the other 2/3 of light. And this is why a monochrome camera is 3 times more sensitive to light, because a monochrome camera captures for each pixel all light available, while the color camera only captures 1/3 of the light available. About the resolution of the camera. We consider quality, what we can clearly see and distinguish on an image, or what the camera can see and distinguish. This is very important. The average factor that we consider for quality is to have a certain amount of pixel covering the size of the smallest detail that we intend to see. How many megapixels are needed is based on the smallest detail we want to see and the area we want to see. So basically, how many pixels are covering a millimeter, for example. How many do we have to cover that small detail? To give some example, like you can see in the slide, a DMC code requires about 2 by 2 pixels for each dot that you want to detect. while a barcode made of long lines needs 2 pixels per line width for the smallest line. Notice that it seems like barcode needs less pixels, but actually the lines of a barcode are much smaller than a square of the MC code, so at the end the MC code is easier to read than a barcode. It needs less resolution. About defect detection, depending on the shape of the defect, you may need one single line of 4 pixels or again a square of 2 by 2 pixels. It all depends how small you want to see and how accurate you want to see. OCR, so character recognition, is probably the most demanding application for cameras. Therefore, we advise 10 by 15 pixels per characters. And those systems normally do have big requirements, very high resolution. The more resolution we have, the bigger area we can see, or we can see smaller. To have more resolution does allow you to rely less on the software to recognize details. So the system resolution is how many millimeter per pixels you have. The less, the better. So the more pixel per millimeter you have, the more you cover. Beside the total amount of pixel, of course, there are other important things about the camera resolution. Beside the total system resolution, so how many pixels you have, how many million pixels, what is important to consider is also the kind of pixel you have. If we have to explain this in a very simple way, bigger pixel capture more light because there is more surface for light to fall on. I made a very little comparison here, a very easy comparison between two cameras. Both cameras have exactly the same sensor size, and that is 1 divided 2.9 inches. One is 0.41 megapixel and the other one is 4 times bigger with 1.6 megapixel. Basically, this camera uses the same kind of sensor. The small camera has got 1/4 of the resolution, total resolution, but the pixels are 4 times bigger. It means that this is a camera which can capture really a lot of light, probably one of the best camera we have about light sensitivity. The other camera, 1.6 megapixel, has got 4 times the resolution, but of course, being the sensor the same size, the pixels are smaller. Therefore, it captures less light. So which one is the camera suitable to your project? Well, it depends what you want to do. With one camera, you have more resolution, so you can see a larger area or smaller details. The other camera has less resolution, but the light is very good, so you can have very good light being captured. Now, the small camera, it's usually used for automations where the field of view is very small. And the bigger camera is used in application where you have a larger area. The choice is yours. There is not so much price difference between the two cameras. I put them down for comparison. But of course, which camera will give you the results more suitable for you? It's a choice that you have to make based on the project. Here we are at the last part of my presentation. This is about lens selection. The first and most important step on lens selection is the size of the lens. The size of the lens is basically determined by how big it is in comparison to the sensor. A lens must be always as big or bigger than the sensor. You can think the sensor is square, the lens circle is round, of course, it's a circle. This must be covered every corner of the sensor. If you choose a lens which is smaller than the sensor, basically you will cut off the corners and the corners will become dark. In some application, this is even not a problem, but just to put it exactly as we also see it, the lens should be as big or bigger than the sensor itself. If you choose a bigger lens, so where there is more glass, more likely those lenses have a better light sensitivity. That's why, for example, a bigger lens for a bigger sensor has got f1.4, while a 1.8 inch lens has got f to 2.8. So if you go a little bit bigger, you will have better light being captured. But of course, the price also is slightly higher. The choice is yours. Megapixel resolution on lenses is not about exactly how many megapixels fit on the lens. It's more a way to determine the quality of the lens. So if you have a 10 megapixel camera, you should use a 10 megapixel lens. You could use a 5 megapixel lens, for example, and it would probably still be acceptable, still be okay. But for the best result, if you use a 10 megapixel camera, you should use a 10 megapixel lens. So these resolutions about the lenses are about the quality of the lens, the best match. That's what we're looking for. Besides those normal lenses for general use, there are some specific lenses. We have a good selection of telecentric lenses. Those lenses are very precise for small measurements and high accuracy. Of course, they are more expensive than standard lens because they are dedicated to such projects. On the other hand, we have the cheapest lenses, which are M12 lenses. Those are actually recommended only for volume project where the price is very important, or for example where you want to have the smallest system possible, because M12 are very compact. They are compact also because there is no focus ring, no iris to adjust, no iris ring to adjust. So basically you have the standard CS or C-mount lenses, you have different quality, different sizes, and then you have telecentric lenses for specific jobs of high accuracy, and you have M12 lenses for volume project and when size matters a lot. A quick summary of the points we covered. Basically, as you can see here on the screen, this is the flow to select the good camera for you for the best price. So the connection type, USB3 is preferred, very easy, cheaper to use, and more frame per second thanks to the bandwidth. Shutter type, global shutter, because it can cope with movement and it makes just better pictures. Monochrome camera is preferred, 3 times more light and crisper pictures. The resolution choice is based on what you want to see in the area you want to see. And last, the lens selection. The lens selection is basically standard C-mount, go for a larger lens if possible so you can capture more light, and go for a matching quality and size. These are the points that you use to select the best camera and lens for your application. And finally, those are our contacts. You can give us a call or send us an email, and I will help you to select the best hardware for the correct price for your project. So based on your needs, we will go together the few options you have, selecting the camera and the lens which is best suitable for your project. Get in touch, do not hesitate, we'll be here for you. Thank you for your attention. Bye bye.